Hello, everyone. Welcome to this ATA Insights webinar. Today, we'll have three experts who will tell us all about how you could make your renewable energy assets more efficient and with digitalization. So I will stop sharing this screen here so you can see us, and I will ask each of the speakers to introduce themselves. So, Patricia, would you like to start, please, and just introduce yourself briefly?
Sure. My name is Patricia Rubio. I am the Director of Engineering for Isotrol North America.
Thank you very much, Patricia. And uh, Patricia, could you introduce yourself?
Yes, thank you, Carlos. Hi, folks. My name is Patricia Nefa. I'm working as a technical director in Reneia, a private-owned utility company in Argentina. Thank you.
Thank you, Patricia. And Danielle, please, before you start your presentation, you'll be the first. So would you please introduce yourself?
Yep. Hello, good morning, good afternoon, everyone. Thank you for joining. My name is Daniel Ramirez Watson, and I work for Isotrol in the Business Development Department.
Thank you very much, Danielle. Well, over to you.
Can you all see my screen correctly?
Yeah, perfectly. Yeah, full screen. Everything is clear.
Perfect. So I'm going to do a quick introduction on our idea of how we improve the operational efficiency of renewable energy assets by using digitalization technologies and other topics. So let's jump directly into the presentation, into the webinar start. So I want to break it down into four main sections. Basically, I want to point out the challenges that the renewable energy industry is facing. And then I want to speak about some benefits, some things that have to go right in order to be able to solve or to jump the hurdle over these challenges, which are the benefits of having good quality data, working with advanced algorithms and analysis, and looking into operation and maintenance activities. So let's go into them. First of all, a quick introduction on Isotrol. We're a technological partner for large utilities and renewable energy companies around the world, working in all continents with over 45 gigawatts of renewable energy assets that are being monitored and controlled by our platform, by our solutions. And our experience pretty much covers the entire value chain, which is renewable energies, trading, grid integration, and control of the assets. So let's start. Some of the challenges that we've seen in the renewable energy plants assets are for sure failures in different types of equipment and communications from various natures. Having different OEMs, manufacturers spread throughout the plants, and some of them don't actually interact with each other as good as we could expect them, or we hope so. Then we always have human error, which is also going to play a role in any project or in any system that we might have. And we can also have the local SCADA system or communications monitoring and control system have failures or present problems. So we wanna talk about in things that we can actually do to try to mitigate the challenges that we have. So one of them is correcting bad quality data and being able to have early detection of problems and perform recommendations. And all of these is based on trying to reduce the reaction time that we have in our assets in order to increase the availability of the same, the efficiency of the devices, and trying to help on the operation and maintenance side to reduce their cost. Okay, so those are some of the problems that we want to solve. I want to show you some benefits of having good quality data. So the quality of the information is key. If you don't have good quality data, you're not going to be able to produce accurate KPIs or information. You're going to be working with false results, basically. You're not going to be able to do early detection of issues, and you're not going to be able to speed up the decision making based on the problems that you might have. And therefore increase what we're saying, increase the operational efficiency, optimize the O&M, and maximize the profitability of the different assets and plants, which is the end goal. Let's look into some of the advanced analytics that we have. So basically, we want to put artificial intelligence and machine learning at the service of renewable energy owners, asset owners. Basically trying to help in the automation and the detection of different problems that we might have in the plants. Very important to be able to talk about root cause problems, actually find what's going on in the plant, put the spotlight on what's going wrong, and be able to provide a recommendation. Sometimes the people that are actually performing asset management might not be an expert on a specific wind turbine or a model or on a specific inverter or on a technology of renewable energy. Maybe they're coming from wind and they have to start working in solar. So having recommendations from the systems that are actually monitoring or supervising the renewable energy assets, it's crucial. We need to know where the loss of energy is coming from. If we don't have a good spotlight on where we're losing our production, we might focus on a problem that it could not be affecting the plant as bad as another one. So that is not acceptable, and we need to have a good loss of energy analysis and breakdown, quantification of this energy losses, and having a look if we can recover it or not. This is an example of different tracker behaviors, the correct tracker behavior that we should have during the early hours, during the midday, during the afternoon, and just having a view of some of the graphs that we can actually see in them that would allow us to identify if we're actually having a tracker blockage, a tracker deviation that is not properly following the correct angle that it should according to the different time of the day, and a breakdown of different energy losses causes here in the right side. Another example, if we can have losses associated to multiple effects, like, for example, clipping, soiling, panel degradation, cooling problems in the devices, a bad design, lack of sensoring, problems with the sensors, bad quality data, gaps in the data, or lack of standardization in the different devices. They're not communicating properly with each other. Black boxes that we might have out in the field with devices that are not sending enough information for us to make analysis. So it's very important to be able to make a breakdown of the analysis of what is causing each energy loss and where they're located, in what device. That's pretty important to be able to make the decision and see where we're losing the most energy. If we go into the wind farms, we can have another set of multiple issues affecting the performance, the power curves of the wind turbine generators, and those could be by external or internal regulation of the wind turbine generators, problems, stops, pitch or yaw misalignment or problems, wake effects by other turbines, or just the resource a resource problem, energy resource problem, or even a power curve deviation from the theoretical manufacturer curve. So it's very important to be able to plot this and be able to analyze it and compare it in the time, and with other devices that could have a similar behavior in a similar nature, or in the same wind farm or in a nearby wind farm. Again, this is just, for example, comparing the bearing temperature of one of the wind turbine gearboxes, compare it with others, be able to compare it with historic data, be able actually to predict what is happening in the turbine. We might not have an alarm, even a warning alarm, but the turbine might be heating up more than any other wind turbine in that wind farm. So definitely it's worth setting thresholds to be able to analyze and predict when something could be leading into a failure mode or a failure direction. And to finish, I'm going to talk about a little bit of O&M, a lot of it related to the COVID-19, the unfortunate pandemic that we have nowadays. Also, some of the evolution that we've seen in this direction, and then the really high need to be able to have all your data and information centralized and usable for customers. So here it's a pretty similar view that we've already spoken about. First, you have to identify the problem, which is what we've been talking about. Identify what's going wrong and where. You have to properly plan the work with the resources that you have. You actually have to execute the work, and you have to report the performed work, and you have to, it's good to perform analysis and lessons learned. So we're going to jump into the planning phase now that we've identified what's going wrong. It's very important to be able to categorize the events by severity, what's happened in them, and also to have either integrated by third-party systems or your own system, be able to know the energy resource that you're going to have, the forecasted data, make sure that if you have to send crews on site, how urgent it has to be, depending on the available energy resource that you're going to have in the next following days, and make sure that you have the necessary resources to perform the work, either in consumables, tools, manpower, supervisors, etc. And of course, know the energy price, the market price that you will not be making because of having shutdowns, preventive or corrective maintenance. Next one would be the execution phase. This is very important to help assist technicians and try to reduce the possibility of human error. So basically having very strong work orders and very easy to perform, to fill out in an automatic way, making sure there's no open loops, and if any information is going to be lost, making sure you're managing your personnel, your warehouses, being able to receive these work orders in mobile devices, also pretty handy, very important, and have a strong validation process, quick, paperless, and having control of the information that is being generated. And at the end, like we said, it's good to run data analysis, to run lessons learned, to be able to know what's happened, how long I've taken, if it's complying with the contractor requirements that we might have. So being able to manage the information that has been produced from the O&M side is also very useful. At the end, as a bit of a summary, we're trying to identify and reduce losses, cater to improving the operational efficiency of the plants, and optimizing the O&M tasks that we're performing in order to reduce those costs as well. So my part, I had around 15 minutes. I think we're on time so far. Thank you very much. And we have the pleasure to count with Patricia Nefa from Genella, who will be speaking last, and Patricia, my colleague, who will be sharing her screen shortly.
Thank you very much, Daniel, for your presentation. Very interesting. I wonder, and hold this thought for the Q&A session, whether you have statistics that compare, what O&M looks like if you have digitalized your information sources, and if you haven't, if you have any comparisons. But in any case, well, Patricia, over to you. But before you start, actually, I'd like to remind the audience that you can send questions through the Q&A box, and we'll answer them at the end. And I encourage you to do so, because you might get an answer to a question you've always had. Okay, so well, over to you, Patricia.
Thank you, Carlos. Okay, good day, everyone. It's a pleasure to connect and participate in this webinar with you. So let's get to it. So here, I want to give you a heads up that although this section is called the power plant controller in renewable energy assets, I will not be discussing the traditional control systems as you know them. I want to introduce you to the latest control solutions. They are being implemented to give response to the most recent challenges that we've encountered. So I'll be sharing with you some of the most recent critical requirements. We will be seeing what systems are impacted by these requirements, and then I will actually introduce you to two types of applications that have assisted us to comply with these mentioned challenges. So here we go. The renewable energy projects become more complex and the demands grow. Clearly, so do the requirements of the systems that are digitally managing these assets. There is also no doubt that the capabilities of the technologies and computing power have also expanded. So we have been put in to look at what would provide the most significant immediate results for the users in the market that are demanding these advances. So when we look at the most recently industry shifts, we identified 3 major points. We're seeing more and more multi-technology projects or multiple manufacturers for the same technology. We're clearly encountering a growing demand for increased performance and ultimately the centralized control. We need to be able to provide a platform that can be accessed anywhere at any time by different users with diverse profiles. And it needs to be able to also to be capable of integrating into third-party systems without incompatibility issues. So when facing multi-technology challenges, we're looking at a demand that asks for a complete integration compatibility. This means overviewing and interfacing with multiple parties, such as traditional controllers or battery management systems, RTACs, generation units, etc. And we're needing to become vendor agnostics. So we're challenged with a new level of control hierarchy. We're adding for this a new layer of applications to achieve this. And we need to do this without virtually impacting the unified response of the integrated system. Our users are demanding a simplified and standardized control overview, which is independent to the technology it's integrated to. At the same time, as it's allowing us to model the algorithms for their characteristics. And in parallel, we're looking to eliminate having multiple subsystems where possible. If not physically, then virtually. We aim to maintain links, our communication links and networking links as close to the source of telemetry as possible, ensuring the quality of the data and other points of importance that my colleague Daniel mentioned earlier. Secondly, we have an ever-growing demand for an even better performance. At the same time that systems integrated become larger and more complex, so for example, we're looking at higher historical data extractions with better granularity, or even just faster processing times. So this requirement for hairy historical data loads are just non-negotiable. They are needed by our clients. This is for various types of processes, from more precise and complex operations and performance reporting to even just warranty claims in which they need to provide large amounts of long-term historical values. And actually, Patricia Nefa will later be telling you a little bit more about the applications that are making important strides thanks to the capacity of successfully managing increased loads of data. So the performance improvements are clearly a challenge. When introducing a new level of control, we need to optimize the communication protocols in response. And we need to ensure that an architecture with multiple subsystems does not add any delay to the final output. So to achieve this, besides from better basic computing power and algorithms, we're demanding to include in our teams the best specialists and professionals, such as database and software architects. And they are who help us to continuously optimize these requests. And ultimately, we're not just talking about the system's performance, but the renewable energy plant itself, the performance of the plant. The production optimization is a must item of continuous analysis. And the third, and essentially, we're challenged with the request for a platform that suits all and everyone. And we mean centralized in 2 aspects. One is to provide a unified dynamic visualizations on company-wide platforms, which, as mentioned earlier, must support multiple users and multiple profiles, all integrated in one. And in the other sense, it is also required to handle multiple production technologies in a single point of control. So now we'll be looking to what systems are those that are naturally evolving due to the previous prerequisites. We're seeing important evolutions on platforms such as plant local SCADAs, control centers, master power plant controllers, and energy management system. With you here today, I want us to focus on the 2 last ones. So these are the MasterPC and the EMS, as we call them. So these two systems that have been basically born to increase the flexibility in the controls design, and they provide better reliability. They are able to decrease deviations and penalties. They're allowing compliance with the most demanding grid codes, and they will ultimately assist in maximizing the power output from our renewable energy asset at the same time as ensuring stable responses to the operator set points and commands. And to help you visualize this, I'm going to take a detailed look at what we're describing. We're going to see an insight on the MasterPPC in a hybrid project application and the energy management system applied to battery storage hybrid farms. Here for a master PPC. So what I mean by a hybrid project is what we often find is an utility scale renewable energy farm, which we either see a mix of technologies such as wind or PV with BESS or PV and hydro and so on, or a project with only one type of technology with multiple manufacturers for the generation units. A master PPC is basically a controller that oversees the other controllers, but it can also directly command the generation units, bypassing these other controllers. It can manage or model a slave PPC as a single generation point. It can perform direct open loop control and dispatch corrected set points, or it can work as the ultimate controller and perform closed loop iterations over the slave systems. In this element, it ideally requires a standalone system. It is best when it's physically integrated into the substation control room, where you can have access to the direct meter measurements and to the control elements. With this, we achieve even faster and more reliable responses. Without forgetting that a master PPC offers the same functionality as a standard PPC. It can provide an active power reference and containment with the difference that this may come corrected. It can work in frequency response. It can operate voltage control and so on. It ultimately restructures your multiple technology farm in one unified response. And most importantly, ensures compliances and warranties and a smoother grid integration. So for this application, I can actually reference a success case in which one of our clients had developed a second phase, a later phase to an extension to an existing wind farm. For the extension, a new group of generation units by a different manufacturer was included in the project. This came with an additional PPC, which was installed with control reference, which were below the main medium voltage bus. This means that they were now contemplating a two-phase project with one previous phase, a PPC that was overseeing the new phase without accounting for it as its own. So without a master PPC, these two phases would have conflicted and fought for production and voltage control, potentially one of them weakening the other's lower phase. So our master PPC was implemented to directly control the two conflicting phases and the two conflicting PPCs, managing an incoming automated set point without adding more than 30 to 40 milliseconds to the control loop. So in a grid code that was extremely strict in voltage time response, the master PPC was able to identify the side with most inertia and compensate. It was able to adjust automatic corrections in real time to evenly distribute the power set points. It was able to provide this response as a single wind farm, which was ultimately what was requested by the grid code. And regarding the EMS that we mentioned earlier, the energy management system applied to a battery storage solution. So the main difference for the energy management system is that it's a service or an application that is often embedded in the plant SCADA, and it may share the plant SCADA database. So it does not require a standalone installation such as what I mentioned before for the master PPC. It is also placed at a higher level in the plant hierarchy for control. So to understand it best, let's take a quick look at how, in this case, storage collaborates in a renewable energy asset. So a battery storage system collaborates in balancing services. It changes the dynamic behavior of our plant. It reduces the stress over the generation units that it's associated to. And it assists on the general system stability, as it's able to provide a very fast and controllable transient response speeds. So with the adequate energy management system implementation, what we achieve is a generally better global automated supervision. It is overseeing the park response to avoid unwanted energy containments or lighting saturations. The energy management system is basically needed to perform tasks such as ancillary and balancing services, as well as grid services for investment deferral or congestion relief. It can include bulk energy management with energy time shift solutions, arbitrage, and so on. So it can work in what we call compound modes, whether they are exclusive or compatible, as it will provide with the priority in which they are each needed to kick in. And at the end, the result, again, is an application that significantly improves the performance and operational efficiency. And finally, I'd like you to understand how these solutions are successfully integrated. As you can imagine, these are not plug and play systems or a one solution fits all approach. There is a careful implementation analysis before it is handed over. Here, you can just simply assume this is a project's timeline from the first preliminary studies to the long-term support, passing through installation, testing, and commissioning. For the engineering and consultancy phase, we take into account the preliminary studies, which they may be provided by the client, or we may participate in some type of simulations needed to complete it. We will often work together with what we assign as a project director, a person usually designated by the client to review with us the requirements, possible power purchase agreements that can influence, grid codes, and so on. And at this point, it is even possible that we identify additional needs. We will then proceed with the design of the models, alarms, and HMIs. During the next phase, the integration phase, we perform what we call the FATs, factory acceptance test, over the prepared systems that has been built according to the previous design requirements. We then move on to install it and integrate it with the different subsystem and site elements. Following this, we start what we call commissioning. It's a phase that includes the final tests and fine-tuning. We perform functional and timing tests, as well as the typical site acceptance tests. And lastly, once the platforms are shown to be compliant and are accepted by the client, we establish an agreement for the long-term support and services to ensure the maximum stability and perform the adequate updates. And just to conclude, with these two last applications that we have addressed here, we can confirm alignment with industry demands. We have actively anticipated and participated to provide efficient solutions to the arising challenges with platforms that have been transformational in the current SCADA software and control market options. So now I look forward to and I hope that you do too, to what Patricio Nefa from Genea has prepared for us. So thank you very much for your time.
Thank you very much, Patricia, for your presentation. So I'd like to remind everyone in the audience that you can send your questions through the Q&A box, and I recommend you do so. And well, we are recording these webinars, so we'll send you the presentations and the recording soon. So Patricio, over to you. Whenever you're ready, start sharing your screen and start your presentation.
Okay, thank you. Just finalizing some details. Well, good afternoon. Good afternoon for everyone. I hope you are listening well. Well, you will. I'm sorry for my French accent, and you will notice some Spanish flavors. So I'm not as perhaps clear and understandable like Patricia and Danielle. But I will try to do my best, and I will try to involve you in a journey that we experimented during this last year in the introduction of asset performance diagnosis in Genea. So my presentation will be quite simple. I will introduce the company very briefly, and then talk some maturity phase that we notice during this journey, and a model that we can compare in the different utilities that have improved this methodology, and then we will try to finalize with some conclusion and lesson learned about this process. Okay. Well, as a company, we are a utility in Argentina that share more or less 30% of the green energy locally. That seems small compared to European or US scale, but nevertheless for Argentina, 1.4 gigawatt it means something, a big number for us. As you can see, we have experimented a big progression during the last 4 years, and differentiation between going green compared to the thermal asset we were declining and selling these thermal assets. In total, we have 3 main types of energy generation. Power generation from wind account for more than 600 megas, which is the most important power generation type. We have also assets in terms of solar and also aeroderivative turbine, gas turbine that provides dispatchable energy to the system. So the first things that you will notice is complexity. Complexity to manage different OEMs, different types of energy, different source of energy. This is one of the big issues that we face every day in operation. Another big challenge we face every day is a distance. Argentina is a big country, and we have more or less 1,000 kilometers between one plant to the other. So it creates difficulty in the time of travel and joining physically these plants. So whatever tasks we can do it remote, whatever we can provide solution remotely will be very beneficial for the operation. Here you can see more or less the distribution, and you can find obviously more information in our website of Genea. So a very young, innovative utility independent that once in the history have catch the wave of renewables energy and have decided to implement since the very beginning of the life cycle of his wind farm and renewable farms, some methodology to increase efficiency. So in my experience, in more than 8 years in renewable energy sector, we have classified 3 different stages of maturity in terms of asset management. And on the basis is that everyone can start from is what we see is the bottom line. No need to have an independent SCADA. You have 1 or 2 wind farm or solar farm. The data are provided by the OEMs through their portals. You have an acceptable performance, but we have limited capabilities to audit what the OEMs are doing. So we have also limited capacity to anticipate events and so be very reliable in terms of prognosis of generation. And of course, you don't have an integrated asset performance management tool. The second stage, which means a little more advanced, perhaps a better, an increased scale of 500 megas to 1.2, 1.5 gigawatts, you take the decision of implementing independent SCADA management. You create a remote operating center to consolidate the monitoring, diagnosis, and communication to the grid provider, and also you increase capabilities in terms of action to be taken regarding the production, and you audit more what the OEMs are doing. But you fail to have automated data diagnosis, and you compensate this by internal resources, meaning analysts that will do their jobs. The next stage, what I call excellence, is the stage in which we all want to be, and probably all of these members of this webinar, is to reach excellence through the automation of the analysis. As we can see, and we saw before, the more turbines you put into the market and into operation, the more panels you put, or solar photovoltaic plants you put into operation, the growing the complexity, the more data you have, and it can create some big problems. So as to illustrate this, I will show this image that I like it very much. And it's an image to represent what we feel in operation every day. When you need this data, the data is somewhere in this stadium, okay? Just as an example, 500 megawatt photovoltaic plant generate more than 80,000 tags per day, meaning a lot of information. And typically, you will look forward to find this information, this data that you need for your optimization. And to find it, it will take you a lot of time and perhaps a lot of money to find it. So it's like to find your buddy or your wife or your friend into a football stadium, and it will take a lot of time. That's the image that I want to represent. So just as a case to illustrate this, I will show you what we face every day in operation. You have several wind farms in Patagonia, and you have to monitor constantly this wind farm. And you cannot have 50 guys to do it. You have a couple of guys, they are the good ones, they are very skilled, but they rely on software and algorithms that help them to do their job better. Okay, for doing this, I take as an example something that occurred in a wind farm, the biggest wind farm in Argentina at 220 megawatts, with a wind turbine, which we noticed from the performance analysis that something was going wrong. And so automatically, in this case, it was a pitch system problem. The system detects that there is something going wrong. It analyzed the behavior, comparing the patterns of the way it should work in other wind farms, and helps the operator or the analyst guy, asset manager in that case, to provide them some troubleshooting inputs and recommendation to do their job. So in that case, the system automatically provides information that enables the asset manager to take decisions. And in that case, we went to this information to the OEM. We speak with them. We say, hey, people, you have a problem. You can see this this power curve in which we have a wind turbine that is rated to 3.6 mega and is not reaching 3.2. There is a problem, and the problem may be this one, and this one. So the OEM, which has generally a full scope agreement, won't be able to say, no, there is no problem, because we are seeing the same thing. We are analyzing the same data. The point is that we are reaching faster and more accurately on where is the problem. So we can tackle and we can anticipate this. In that case, having discovered that there is a problem,
Tracy, I don't know why, but I seem to have lost the sound coming from your end. Can you try again? Can you try speaking again, or and to see if I can hear? So now your microphone is on mute.
Okay.
Okay, now I can hear you. Yeah, perfect.
Okay. Sorry. Something I did not touch anything. Sorry, Carlos.
Mysteries of technology. You know, it's fine, but yeah. Thanks.
Okay. So sorry for the disturbance. So at the end of the day, we noticed that in this case that we lost some energy during these 4 days, but we could have lost a lot more of energy if we did not provide this information accurately. So this is my last slide, just to give you the hand, Carlos. I will. This is my motto as a lesson learned to share with everyone. You cannot optimize what you don't control. So that means that if you are just a spectator, you will see the wind farm running well, your asset running well, but you cannot optimize it as you wish. So there are 4 major learnings. The first thing is to adapt existing asset performance management or diagnosis solution according to your maturity curve and context. The only thing you will find in the market a lot of solutions. My advice is to take whatever solution can be independent from the ODMs and should be technologically agnostic to be adaptable to every platform or OEMs, Nordex, Acciona, Siemens, Gamesa, Vestas, and so on. The second learning is the loss of energy prevention and anticipation in the decision-making process are the best way to defend with your financial director the return of investment of implementing this solution. Because of course, this solution will mean some cost, but this cost can be repaid by the loss of energy prevention and anticipation. Okay. Something that is very specific to the context we are all experimenting, even in Argentina, in that the moment, I'm sure in US and Spain also, due to COVID-19, operations are in the first line of defense. So that means that something that in the past was an alternative, an option, now is a must. And this must should be implemented hopefully long before, so as to take action in order to optimize your production. Each time you send a technician to fulfill a work order, each time you are displacing some technician from one place to another, you are taking risk. So all activities that you can carry out at distance, remotely, and to help these guys to in the process of troubleshooting to tackle the issue should be rewarded. And it requires necessary adaptation to your systems, and it requires time, and of course a change of mindset. All the virtual reality enlarged activities or digital process will be welcome in this process. And as a last comment, once your asset performance management or diagnosis is implemented and results are tangible, probably you may be interested in providing service to others, because you have the knowledge, you have the technology, and you have set up a remote operating center that can benefit others with, of course, a package of solutions. So at the end of the day, I can say to you that we are very, very happy with this innovation that we implemented recently through Bluance and Isotrol software. And we look forward to expand this case, which was used only in one farm, to others, and to explain to our organization that it works, which at the end of the day, as operation guy, is what we're looking forward. Thank you very much, and sorry for the technical problem. That was not my responsibility. Thank you.
No, thank you, Patricia. It's one of those things, you know, it was only a couple of seconds. And by the way, your accent is absolutely fine and perfectly clear. So So, right, well, we have a few questions here. So, very interesting points. Before we actually answer these questions here, I'd like to ask, you mentioned, Patricia, that one of the ways in which you could, sell these kind of solution to your finance director is by showing how much the loss of energy you could prevent by implementing this solution. Do you have any order of magnitude of the savings that you could obtain by implementing these kind of solutions?
Okay. It's a question for me, Carlos.
Or for anyone who wants to take it, not asking, for specific dollar numbers, but, like an idea of, the orders of magnitude of how much you could be saving.
Perhaps, Daniel, if you allow me, I will answer, because I experimented and I live personally to convince my financial director. Well, in the beginning, we were in the basis phase. We were very artisanal. So the first phase was to implement Bluence. And so APD is a step forward toward excellence. Our lesson learned is that with the implementation of this independent SCADA, we can have around 3 to 5% of increase of energy production, or avoid of loss. Is the same, basically the same. One particularity of Argentina is that we are far away from everyone. That's the first thing. The secondly is that we have high capacity factor. At that moment, in south of Patagonia, we have a capacity factor of 60%. So it means that every day we lose production, we lose a lot of money, because in Argentina at that time there is no curtailment, and every megawatts that you can produce from your wind farm is a megawatt that will be sold into the market. So it means a lot of us. And since we are far away from everyone, bringing parts, bringing expertise, bringing repair personnel, it takes time. So if we have time to anticipate and to notice the problem in advance through CMS, through predictive maintenance techniques, and through this SCADA, we take measures and we take a step forward towards reaching a better time frame between the problems appear, the problem is solved. Daniel, if you can complement.
Hard to complement that. I'm glad to be able to say that. I think it was a very, very good explanation that you showed the journey from basic to advanced to excellence, and how you've been able to share some of the figures and some of the particular solutions that Geneia has in Argentina, but anyone can have around the world. Very good, thank you.
Patricia, do you want to say something, or
no? Agreed.
Should we go to the next question? Okay, so well, we have a question here. The first one on the list: does your MPPC coordinate directly with the turbine control, or is there any other layer in between?
The MasterPC can do both. We've seen our ideal solution is where we directly control the turbine PLC. The next option will be to control the turbines through their own power plant controller. And we've had more intermediate responses when we've had to use another layer in between, because physically it wasn't possible to change the existing communications architecture.
Okay. Well, we have another question here from Arati, and it reads: do you think
there's one question that I moved to responded already from Constantine. I think Patricia was gonna go for it.
Would you like to answer that live?
Yeah, so that's
is that one that one reads: data availability will depend on the communication channels, SCADA channels made available by the OEM. How can you best align and agree on the availability of data with the OEM, analyst and operator, applicable to wind and solar power plants?
And Patricio spoke for this a little bit, the challenges that Geneia is having with this, or had with this.
Correct. There is also all types of situations. We tend to go strictly to the operational manuals that these O&Ms can provide to us. There, they will list where the full data availability that they should have in the systems, and we try to negotiate and agree with them to provide us the full integration where possible. The SCADA channels are, yeah, of course, are made available. The channel can be there. I think the criticality point here is how many points we can interface, or they will be willing to interface with the SCADA.
Yes, if you allow me, Carlos and Patricia, something we saw in advance is that before signing the OEM contract, if we can introduce some remarks according to what explained Patricia, is that the OEM should not only provide the turbines, but also access to our data, because it's your data. You purchase it, you generate. So that means that these data are your property and should not be, I would say, should not be avoided the access. Okay, so obviously the OEMs does not welcome bring this information, and so there is obviously some friction. My advice is to set up this way of collaboration beforehand the contract of OEM is signed, because in that phase you can perfectly explain that you will use a standard interface or PCDA, whatever, there are plenty in the market, to allow you to connect the data with the information and to codify the signals.
Okay. Right, so there are a couple of questions on standards and communication standards. So I think, if you'd like to, answer that one, Patricia. It says, do you think to make SCADA communication smooth and the PV inverter plus PPC controller for SCADA and asset management vendors should deploy a common communication protocol or platform? What are the global standards used for digitization of renewables? So
great. So yes, of course, that will be ideal if we had a more globalized standard for communication protocols. But it is the case right now, but it's not. So there are protocols that we're seeing are more standardized globally. We're seeing the IEC 104s, the DMP3s, and depending on, if we're talking about protocols that are going to be shared over VPNs or that are going to be shared over a local plant network, we are seeing some kind of a standardization. Globally, it is very, very difficult to achieve. But what we do propose our clients when we have repeated opportunities with them is that we try to standardize the protocols that they're going to be maintaining over time. So especially clients that are later going to become their own OEMs, it really facilitates it simplifies the long-term maintenance if we have standardized protocols that are deployed in their own fleet. And right now, that's as far as we can collaborate in this standardization.
thank you. One thing is not a question that is being asked here, but one thing I'm curious about is, I suppose, your SCADA systems and all your controls generate a lot of data. So and I'm sure that, you would have some readings that are not accurate, the sensors might be damaged. Do you have any protocols to actually weed out spurious data?
I'll take that one, Carlos. It's a little bit tied with the previous question, the smooth communications. At the end, we recommend that the owners try to involve their partners or their suppliers as early as possible in these projects. I know that there's RFPs that go out, and a lot of times you don't finalize a contract until the very last moment. But by bringing the experts in early, they're able to guide you on the communication protocols that you should be using, analyze the different OEMs that are going to be participating in the project, talking to them, seeing if they can solve issues that have happened in the past. And specific to data quality, a lot of it goes with the communication power and reliability that the different OEMs have with their devices from site. What can we try to do to mitigate data quality problems and therefore problems with the KPIs, which is going to be critical. We can set up automatic data quality correcting algorithms because, like you said, we have so many tags, we have so much data that it's happening in a site that if you have to do it manually, this is impossible. It's completely impossible. So the other thing is by connecting with partners, with suppliers early, you can actually work with them and agree and say, okay, let's set up this 20 data quality algorithms that are going to automatically correct data. And let's agree on what kind of formula, what kind of algorithms each one are going to have. So you're able to implement all of these solutions ahead of time, make sure that they comply with what you want. And also provide the end customer that if they want to make a change manually, is like Patricio was saying, the data is from the owner. It cannot be captive. So if you want to make a change manually, you should be able to go into the system and type in that data and upload it.
Okay. Thank you very much. Right. Well, there is a question here that has to do about the size of the asset. So, from which kind of capacity level do you think it is? You would really realize the full benefits of having a full digital control system.
If I can take that one too, please. I think it's a little bit aligned with Patricio's message of having a basic system, relying on OEMs, then trying to go for more advanced systems, standalone systems that the utilities control, and then trying to go for the excellence. So it really depends on the grade of maturity that the utility or the company has, if they actually do technical control or high-level asset management, the type of plans that they have. But typically for any utility scale project, it really pays off with the kind of energy prices that we have, and the energy losses are not acceptable. Utility scale plans are definitely beneficial to look into this type of systems and solutions and trying to mitigate the energy losses that you have. For smaller systems, again, try to involve your supplier as early as possible so these analyses can be run before making a financial commitment.
I fully agree with Daniel. It's something like, imagine that you have a baby and this baby have a clinics, historical clinics book. I don't know the exact word in English, but everyone that is born has his clinical book, and it goes with all your life. Well, this child is yours. You finance it, you set up, you build it, you operate. So it is your child, and you have to have the good information from the very beginning of his birth. So implement this SCADA or independent SCADA and all these asset management solutions in the middle of the life. It pays, but not as much as having all the historical life. You can see which system have more failure. You can get some statistics with all the data you can gather, and from this you will have more possibility to explore and reach some conclusion that sometimes are painful. Do you have a serial defect? Do you have a problem in your gearbox and it's contaminated with one batch of production? Do you have a problem from one brand of sensors, or whatever the types of problems that emerge during operation? But you have to have on the beginning of your life cycle, not in the middle, not at the end. So wherever you decide to do it with confidence that it pays off, and do it in the very beginning of its life cycle. This is my experience.
Thank you very much. Well, we have come to like the end of this session, so I'd like to thank everyone who's been with us today, and also our three speakers. Thank you, Patricia, Daniel, Patricio, for being here with us today. So, well, don't know if you have any parting words for the audience.
Thank you very much, and we'll make sure that all of the questions that have not been answered live, we will answer them by email for sure. Thank you very much.